Okay, previous lecture, we covered these two types of chart, P chart, C chart. Basically, the main difference is the axis, y-axis and the data you use. Y-axis is a proportional. Again, how to calculate proportional? You calculate by converting how many sample each time you take. Okay, so let's say each time you do 100 sample, you need to convert the defect number, let's say 1 into proportional, this one, defect, a proportional number. So this one is 0.01. If you get 1 out of n equal to 100 sample each time. Okay, then you plot. Last time we cover P chart and C chart, right? The conclusion, if you see the question asks you about plotting the chart, you want to see your conclusion, the trend. You need to discuss about the trend. Either, okay, first one is in control or not in control, or not. Second one, you talk about the trend, either go up, go down. Then what is the corrective action? Okay, corrective action. This one, a few main points you can do. Machine tuning, or calibration, reskill or training. You give training, or you set in some tools like checklists or QC standard and so on. So these are the expected answer after you plot the graph. After you find the mean, upper limit, lower limit. LCL is lower control limit. UCL is upper control limit, upper, lower. Okay, there's a formula. Okay, the formula LCL, UCL. The formula will be A plus minus Z sigma. We always look like that. Okay, it depends on what graph you want to plot. A plus minus Z and the sigma. Okay, so it depends on the question. The Z is the one that you'll see in the question. If the say that the sample is 99%, 99 point something percent, Z is 3 because this is 6 sigma. 3 on the left, 3 on the right. 85%, 95% will be 2. 60 something will be 1. Okay, so Z number is automatic from the question. Then the rest, sigma, they all have their own formula, right? Okay. So this one already covered. Each set have its own way of calculating the sigma, right? So last time we already discussed about this example 1. Okay, and we plot the graph, and from this graph, 2 points out of control, and the trend is going up towards the upper limits, towards the. So when talk about trend, it must be from, it must be pointing towards where, either towards upper limit or lower limit. Okay. Then we also cover C chart. C chart only focus on the number of defects and don't need to convert into proportional. So you just count by defect, and also the way of calculating the mean for the C chart also given. Okay, the sigma is square root of your C bar here, or the mean value. Mean value. Okay, so this one, I ask you guys go and read, right? This is your homework for C chart. Okay, just calculate the number of defects, then convert the mean for the defect. Okay, you total up 190, then divided by how many sample you take. You get one value, then you can take this value, square this one, you get the sigma value. Okay, So once you plot, you put in all the numbers inside there, up, down, down, right? So if this one come out in exam, I'm not very particular in the I'm not very precise in that one. But if the number, let's say, is for example, I'm only more interested seeing the trend. Okay, but the point please given, please put inside there. For example, here you got 15 points. Please make sure all the 15 points are on the correct location. I'm not going to measure like whether you draw the correct scale of this one or not. I'm going to see, like, for example, example 1 is 12. 1 is 12, so I'm going to see 12 here, for example. I'm not going to see whether it's according to scale or not, right? So it should able to show like what you have to label, like your mean is what? Draw a line, or you can write here what is your mean, what is your upper limit, what is your lower limit, write the number here. Okay. Okay, so like this one is all the numbers, all the dot is within the two control line, then it's in the control. Okay, you can write also proposal. Your correction here is just that continue to monitor the quality. Okay, next one is just now P and C chart. Now is another chart we call range chart. Range, we have another two range chart, and another one later you'll see is a mean chart. Mean of the mean, you'll see double slash there. Right. So R chart is for amount dispersion of sample. Then mean chart is use average process, especially the sample size. This one variable. This is variable control for continuous variable that can measure, for example, weight and volume. Right. So this one you read. I'll just show you how to do the mean chart. Okay, so these are the checkpoint or how you make decision. So what kind of chart you use is depending on the information you have. If the standard variation is known, then formula using standard variation can be used. But if you do not know your standard variation, then table of value based on sample range is available to develop. So it depends on which one. Okay, so for mean chart, also A plus minus Z sigma. So here, if you are asked to plot mean chart means you take the mean, you find the mean of the mean, double slash here. Okay. Okay, what mean by mean? Means you add all the mean in the process, you divide by the sample of the group. Okay, you'll see the table something like this. You see something like this. So for example, this O-ring is a ring bearing. So you have observation 1 to 5, and you have you'll see the mean in the table. So when you see mean in the table, means you take the mean of the mean, you add all these things divided by 10, you get mean, or X double bar. So this is a tooling company. We have this observation. So you want to plot a graph. So employee have take 10 sample during the 10 days period of 5 ring and measure diameter of the ring. So each time you take 10. Each time you take 10 sample for the 10 days. So 10 days of 5 slip bearings. Okay. Individual observation of each sample is shown below. Okay. Now then in the question it say from past historical data, it know that process standard variation is 0.8. So your standard variation is known. So X double bar is take the total average divided by 10. Okay, control limit again is plus minus z sigma x. Okay, now how to calculate sigma x is depend on the sample size. In here, your sigma is 0.8 divided by square root of 10. Okay, then you get your UCL and LCL. Huh? Okay, so this one, how you get the value is from here. Sigma, this one get from your standard variation divided by square root of your K. Right. So you only need to be careful on the sigma. Different graph has different sigma, the way of calculating sigma. Okay. Then the rest, you start with the graph on y-axis, x-axis, then plot your mean, draw the mean line, draw your upper limit line, lower limit line. Okay. Then after that, you can observe from the table or from the graph. So here, from the table, you already can observe like your upper limit is 5 something, lower limit is 4.9. You check the average here. You check the average. Average here is 4 within 5 and 4. So this one, all the data is in control. Okay. You can either plot chart or straight away use URC, LLC to find the whether it's in control or not. But maybe you're not good to see the trend. You can see whether the trend is going up or going down. So as you can see from table, it's actually going towards the ULC. Okay. Your ULC is 5 something, L lower limit is 4. You see the average 4, then it keep increasing to 5. So actually it's going up to the ULC. Okay. So if this is a tooling company, so correction, you do calibration, you do tuning, or you do reskill of the workers or operator, or you use a better tools, or you have set up a standard QC checklist. Huh? Okay. So just now, this example, you are given the standard variation. You know the standard variation case. Another case is that you don't know the standard variation. Then you use this formula. Okay. If you don't know standard variation, or in the question is not mentioned any standard variation, and you need to plot mean chart, you need to use this formula with the constant value A2 from a table. From a table. So this one already show you how to find the X double bar. And there's a R hatch there. So you need this table. You will see this one in your appendix question, your question appendix section. You will see this table. So you will see N sample. Factor for X bar already show you when to use this one. So this factor is for mean chart, but mean chart without standard variation. Then you use this column. Okay. Later we'll look at R chart. We look at D3 and D4, but now we look at the middle part here. Okay. So this chart will answer how to get A2 value. Okay, I'll show you this example, how to get mean chart, but using this formula. This is without standard variation. You don't know the standard variation. Okay, so here also tooling, you want to develop X chart, sample data collected for this process in the range shown in table below. Okay, so now you have your X bar and your R. Okay. Okay, what is your R? R is a range value. Okay. So the company want to develop a mean chart to monitor the process. So what we do, this R bar or average of R is compute by first determining the range of each sample, by computing the difference between the highest and lowest shown in the last column of table here. Okay. So you take sum of the R here divided by the K. So in this case, 1.5 divided by 10 sample. So your R bar is here. Then you use this UCL, LCL formula, plus minus A2 value. So this one, for this table, you don't know the standard variation. So you find A2 value from the table. So again, X bar, X double bar is you take all this value, 50.09 divided by 10. Okay. Then you go to, you have these two value, then how to use A2, this one. So your number size is 5. Okay, this one, the N number size, we'll use 5. We'll use 5. Why? Because in the question just now, it say that each time it takes 5 samples. Let me show you the step first. Okay, so in the table also, it will tell you like 1, 2, 3, 4, 5, 5 times. Each time it takes, like for example, sample 1, it takes 5 times, 5 measurement. So 5 measurement is N equal to 5. So you go to this table at the back, 5, then you use the A2 value 0.58 in your calculation. Okay, so maximum that you can measure is minimum 2 value, maximum 25, means the number of sample per test is using this one. Okay, so we have 2 value. Then you put inside this ULC LCL formula. Then you find the value and you make a conclusion. Right? So you draw the graph. Y-axis now is range, so it's X bar. Number of sample is X. Draw the mean, draw the upper limit, draw lower limit. Put in the numbers in your line. Then you plot accordingly. For example, number 1 is 4.98, so you plot 5.98. Just put the location inside there. Then see whether the process in control or not. In this one, the process is what? In control, out of control. One point that almost missed with is point number 9. Point number 9 almost want to out control already. Okay, but it's bounced back to the mean, this one. However, in general, the whole set of data is towards the ULC. Okay, so again, when you see plot chart, you need to mention whether this process in control or not in control. Why? Because if you say in control, means all the point is within ULC and LCL. Okay, if it's not, then say how many point out of control. How many point is above ULC? How many point is below LCL? Right? If it's not in control, then tell about the trend, either go up or go down. Towards where? Okay, then propose correction methods. So for example, this case, how you correct this one is that, again, these three, you talk about human error, machine tuning, rescale, or you have a checklist. Okay, maybe this sample out of control, near out of control, maybe the worker is talking during the sampling. Right? Okay, so our chart is the same thing, only the different formula. So for our chart or range chart, you use this formula D4 and D3R. Only need to be differentiate. The lower one is 3, upper one is 4. Okay, And how to find R bar is changed, is the one that you see on the screen here. Okay. So you're using the table. So I'll give you an example. So same table like you see in example number 4. Now we look at example number 5. So you want to find R chart. So R chart you can find is 0.115. How to find this one? You take total R divided by sample. You get this number. Okay, then now you want to plot R chart. You go to the R chart here. D3 is low value. 4 is upper value. Okay, so you use a formula. Again, you need to know where to read lah. So number each time how many sample you pick is in this example is 5. So you go to 0. D1 is D3 is 0. So here is 0. Sorry, LCL is 0. ULC is got something lah. 2.11. Okay. So you have 2 lines. One is 0 point something, but your LCL is 0. So your graph will look like this. Okay. So average, your LCL will be on a 0. Your mean will be on 1.1. UCL will be on 0.2. Okay. Your range graph, you can see that the range actually is stay within the is in control. The range is in control actually. Okay. Okay. So because it's the same table, same process, same company, you're plotting X bar or mean chart to range. All right. So example 4, the process is not in control. However, the R chart suggests that the process in control. All right. So and the range of number 8 and 9, 8 and 10, number 8 and number 10 is very near to the mean. All right. So you need to compare these two to see whether it is how you fix the things. How you fix the things. Okay, so this is observation, or we call it run. So this is run number 1, number 2, number 3, number 4, and so on. So this is how you write the observation. Okay, so this observation is constantly below center line. Is in control but is below center line. This one in control but above center line. This one is consistency is moving towards UCL. This one moving towards LCL. Okay. Okay. So this is another revision chart. So if you understand what we talked about 5 minutes ago, then this one is just a revision for you. So you see this one actually is a flip chart of the sigma graph. Okay. So this one is the mean. Then this one 1 sigma, 2 sigma, 3 sigma. Okay. This one is a mean chart. This is a mean chart. So you see X double bar here is a mean chart. So here it depends on how you calculate first sigma, 2 sigma, 3 sigma. Okay. So if you are plotting the mean chart, you actually can divide into first sigma, second sigma, third sigma region. Okay. So you know that you break the graph into 3 zones above, 3 zones below. Okay, and we divide by this is first. The yellow color is sigma 1. C, B is a zone 2 sigma. Zone A is a 3 sigma zone. Okay. So this is called pattern test. Whether it is whether it's the okay, this is called pattern task, whether it is in how many in the zone of A, B, and C. Okay. So you have zone 1 sigma, 2 sigma, 3 sigma lah. Okay. So this one is called you determine whether your data is random pattern or non-random pattern. Whether, right? Non-random means there's a human factor that affect the things. Something must be wrong with the machine or with the people. Random means something that you cannot control. Which is even though you improve the machine, you improve the human, something will just happen. Random, yeah. Random pattern, for example, when you manufacture steel, you cannot control the density or the carbon percentage for the overall steel, right? There's a carbon distribution at a certain area, right? So that is random, unless you have a very advanced tooling that you can control the distribution of the carbon percentage. Yeah, you means you very hard to control one. It's like, yeah, suddenly got three point at the top or 3 point at the top one. Okay. So this is just a recall, 3 sigma and so on. Okay. So this is some checkpoint for you to observe, general guideline to observe whether what happened to the pattern. So you want to identify the patterns in control chart when none of the observation is beyond the control limit. So there are 5 here. So 8 conservative point on one side of the central line means something wrong with, is a non-random already. Means something wrong happened towards one side, either on the high side or low side. Something must be happened. Means it's not random process. Okay, so if you have more than 8 points that is on one side of the mean point, then it's a non-random process. Means something must happen to the machine or to the human. Okay, or to your formula that you can control. Or add consecutive point up or down. So number 2 here, 8 consecutive point up or down, means it continue to, like this case, it continue to go up consecutively, 8 points. 14 points alternate up and down. You count 14 points up and down in between this one. 2 out of 3 consecutive points in zone A. This is zone A here. 2 out of 3 consecutive points means you have 3 points here. 2 out of 3 in zone A. Consecutive point. It must be continue like 3 points like that. Like that. 1, 2, 3. And then this something happen, non-random. Okay. 4 out of 5 consecutive points in zone A or B. In zone A or B. So means 5. 4 out of 5 means like that. Means something wrong with your data already. Not data, but with your approach or with the process. It's not random process. Okay. So this is a checklist. This is a checklist. So for example, you're seeing this kind of pattern after you plot the graph. This is for control as a mean chart. So for mean chart, sometime in one of the section, it asks you to check whether this is random or non-random process or pattern axis by using these 5 arguments here. So here, if you see this graph, it violates rule number 1, number 4, number 5. Number 1 is what? 8 consecutive points on one side. You count 1, 2, 3, 4, 5, 6, 7, 8, more than 8. So violate rules number 1. Number 4, 3 out of 3 consecutive in zone A. Zone A here. So 3 out of 2 consecutive line are 1, 2, 3. 3.2 out in zone A. So it's considered out lah, non-random. 4 out of 5 in zone A and zone B. So count here lah. So there are 5.1, 2, 3, 4, 5. Or here. Okay, so you count here. 1, 2, 3, 4, 5. Out of this 5, 4 is in A and B. A and B. Okay. Now number 6, I go very fast. This one you can read during your free times. I just want to show you how to do. So if you're given the same chart and you plot the same graph, so either you can see this one from your chart, or you can, if you're hardworking, you just do up or down zone A, B, and C. Okay, so zone A, B, and C, how you do that is that you divide your chart. Let me see if I have the chart. So this one, you can divide into 3 regions. This one, the graph you plot just now, you can split into 3 regions. You calculate this one, means, or you take this one, you calculate 5.01 minus 0.08 means 7. The difference is 7. From here to here, 7. Divide by 3. You understand? You understand what I mean? This is upper limit, UCL. This is mean. Okay. So you need to split into 3 equal area. So this one, 3 sigma, you already just now you're using 3 sigma just now. This is your UCL line. Then mean. So what you do is that from this example, 5.08 to 5.01, you want to go for a long way, can you use this formula, you calculate what is a 2 sigma, 1 sigma. You want a fast one, you calculate the differences between here, 0.07 divided by 3. So it's about 0.02 something. So you divide this one, you calculate 0.02, 0.02 something. Then you draw a line. You don't need this line, you don't need to draw very hard one. You just need to dash, 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 or gray line, something like that. Just to help you to split into zone A, B, and C. Okay. Then you observe, this one is more hardworking one. You follow the procedure, right? So you have this 3 line, you write so this 3 line, then you observe whether it is violate any rules here. Okay, so in this example, in example number 5 just now, so number 1, 8 consecutive point on one side of the center line. So center line is here. So number 1 doesn't more than 8 points. So 1 don't have. Then you check 2, 3, 4. So 8 consecutive point up or down. There's no consecutive point up or down. Right? Okay, 1, 2, 3, 4, 5, 6. This 6 is going up. Right? 1, 2, 3, 4, 5, 6. But the checklist here is 8. So do not violate. Then you find 14 point alternate up and down. You count got all up and down or not? No, don't have. It's either up, down, then up, then down. So number 3, okay. Number 4, 2 out of 3 consecutive point in zone A. You calculate. Got zone A is here. Zone A is here, right? Got any 3 points or not? No, only have 1 here, 1 here. So 4 also don't have. 4 out of 5 consecutive point in zone A or B. So you calculate the last one. So last one is here. 1, 2, 3, 4, 5. So this one is on the mean. So also don't have. You need 4 out of 5 to be in A or B. you only have 1, 2, 3 points. So you don't have, so in here, it is a random pattern. You're having a random pattern observation. Okay, so here you add one more. So here in control, not in control, trend go up, go down, corrective. Then one more here is random or non-random pattern by the 5 rules. Okay. Okay. Then this one is another elaboration. This one you read. So whether it is a natural variation or there is a process controlled, like very narrow, the process very narrow, and in meeting the 90%, almost 99%. This one is about 70 or 65%. This one is very narrow, process capable always conforming to the specification, because the left to right, left right is your control limit. So if your sample process is within the process, this is conforming, we call it conforming the specification. This one a bit out, a bit out. So the process off-centered, capable, but some output will not meet upper specification. Okay. So this one out already. Okay, this one out already. Here is out. Okay. So if you're in the industry later, when you see this kind of chart, what you do is means that you need to do calibration on the machine already. The central point of the machine is out already. So you see the distribution actually is a normal form, but the mean point shifted. The mean point shifted to the another side, right side. So you need to do calibration, right? Or this one usually your reference point is out already. Okay, your reference point. Or the jig had problem already. The jig reference point got problem already. For example, metal stamping, this one you get this one means the jig location, one layer and another layer shifted already. And maybe one pin is broken, so the whole stack of jig was shifted. Then the whole block shifted. Okay. Okay, we have done with the control chart. Okay. You guys can continue or you want break? Break. Okay, break. Okay, we continue 3:05, 10 minutes break.